In this module, we will learn about how you can build a conversational language understanding model using Azure AI language service. So, as we already know now, what is NLP? It is a branch of artificial intelligence which enables your software to understand and interact with human language in a text or a speech form. So basically, you will be able to interact with your system in more of a human language. So it can be either in the form of text or in the form of speech. And here the objective of this particular technique is to enable your software to interpret and then process and generate the human language in a meaningful way. So basically, we are trying to make your system understand your language and then process it, understand from that language what is the meaning that particular user is trying to say, right? So that is nothing but natural language understanding, wherein you are making your system to understand the semantic meaning of the natural language spoken by a user or provided as a text input to the system, right? So here your objective is you can use your trained language models to interpret users' intent from the natural language input. So here this word intent is very important. Here what we are trying to do is make our system understand what user is trying to ask him to do, right? So let us understand what is the common design pattern that you follow when you design any NLU solution. First, you will be defining your input. Here, your application will be accepting the input in the form of natural language from the user. So it can be in the form of text or it can be in the form of spoken speech. And now your language model will determine the semantic meaning. So that means it will process that input to determine the meaning or to determine what actually the user intent is, what user wants system to do. Okay, so once it has processed that input and it has understood, it has identified what intent is user trying to say, then it performs the actual action. So after determining the intent based on the user's ask, application will take an appropriate action. So it can be something like answering a question that we have seen in the previous module, right? In the question answering solution. Or it can be something more than that, that is nothing but performing certain tasks, right? So now let us understand how you can use Azure AI language for your natural language understanding solutions. So here functionality for your Azure AI language would be to enable developers to build the applications that can leverage language models for natural language understanding. So you can use your Azure AI language and integrate it with your applications so that you can build a trained model which can be used to do this particular task of your natural language understanding. So you can train this model with relatively very small number of samples. So it will help to understand and respond to user based on the input that is given to your system. So let us see how it works. User will provide a natural language input to their application. So this is your application wherein user will be giving a input and your language model. So here your language model will process this input. It will try to understand the user's intent and your application will perform the action based on the intent. So if you see, here is a bidirectional. This is your model in your cloud, okay, built using Azure AI language. So your application will provide the input that it has received from the user to your model, and model will process that input. It will try to understand the user's ask and it will inform the application to take that particular appropriate action. So this structured approach will allow your developers to create intelligent applications which can interact naturally and effectively with the users by understanding and also responding to their inputs. So here we are not just trying to provide the answer to your users input, but here we are also building a model which can do some appropriate action. So basically, based on the user's question, it can take a appropriate action there. So let us understand what are the pre-built capabilities of your Azure AI language service, which helps you to build such kind of solutions. Okay, so there are various pre-built features. We've already earlier also seen those features which helps actually to build this kind of model. So these features can be used to communicate with users, understand the incoming messages, gain insights on the user's intentions and questions. So based on these features only, your AI language model will be able to understand the user intention. There are two categories of features that is your AI language service has: pre-configured features and learned features. So pre-configured features are nothing but ready to use without any learning. You need not train any model. And coming to learned features, these features require building and training your custom models. So most of these pre-configured features we have already seen in the first module. So it's like summarization, wherein you can your service is your AI language service can summarize your documents and conversations into key sentences. Basically, it can uh, extract the main points from the long articles. It can determine what exactly is this conversation about. Okay, and then you have something called named entity recognition, which can help it to extract and identify entities like people, places, and companies. Like it can identify Seattle as a location. In the text, the waterfront pier is my favorite Seattle attraction, right? It can also detect PII information, which is personally identifiable information. So it can identify and remove that sensitive information from your emails and addresses, right? So it can remove the email address from your text. It can also extract key phrases. So it can extract main concept from your text. So if you have a text like text analytics is one of the features in the Azure AI services. So it can extract the key phrases here like Azure AI services and text analytics. It can also do sentiment analysis, which is nothing but identifying whether your text is in the positive sentence or is it a negative sentence, right? So it can identify great hotel close to plenty of food and attractions we could walk to as a positive sentence. And then it can identify the language. So which language is the text given to it? So it can identify bonjour as a French language. So basically why we are looking at these pre-configured features here is in order to build your conversational language model, these are the features of your Azure AI language which actually helps it to understand the user's intent. Okay, so these are some of the pre-configured features. Apart from that, there are some features which you can make it to learn. Okay, so whatever we are studying, that is one feature that you are trying to make it to learn. That is nothing but your conversational language understanding. Here you are building the custom models to predict the intent and extract the information from the user utterances. So here you need to give data, you need to tag your data to train your conversational language understanding model. So as we have seen a pre-configured feature called named entity recognition, you have another feature wherein you can train your model to do the named entity recognition, which can be custom specified entities. Okay, so you can train it to extract the custom specified entities from your unstructured text. Okay, so you can provide some labeled data, you can train your model, so then it will be able to identify those custom entities. Okay, so this is very much useful when you want to recognize the parties involved in contract documents, let's say. Okay, so these are some documents related to some particular domain, let's say. So you can train your model to identify the parties or identify the text related to that domain, entities related to that domain in your some contractual documents, let's say. Apart from that, you can use or you can train your AI language to do custom text classification. So here you can classify your text or documents into custom defined categories, right? So you can, let's say you have articles which belongs to news or entertainment or sports, and then you want your system to classify those documents. So you can train your model and you can specify with some particular categories of data, and then it can help you to do that custom text classification. So we have seen question answering. So you can provide question answers based on your input documents like FAQs or your websites or your some kind of documents or some contractual documents that you have. So you can use these FAQs to create virtual chat assistants that can answer your common questions, right? So why we are looking at all these features? So all these features are nothing but which makes it capable to create something called natural language understanding models. So now let us understand how you can build a conversational language model with Azure. So first of all, you need to create a language resource. You go navigate to Azure AI Services in your Azure portal, create a language resource, submit all other details like name, region and all. And once you have created your Azure AI language service, you will be able to retrieve the key and endpoint from your resource overview under keys and endpoints. So we will see all this in your lab demo. I'm just telling the steps that is involved in building your conversational language model. So once you have created this, then you can go to Language Studio, which is your interface that allows you to build, train and deploy your models visually, right? So once you have gone to Language Studio, you can create a conversational language understanding project there. Okay, and once you've created this project, then comes your training and deploying your model. Okay, so you can use the REST API to do all this deploying your model, checking the deployment status, querying your model. So I'm just telling few steps, but it I mean, before even deploying your model, there are other steps involved like training and all. So that comes when we see the lab demo. So here just you need to understand how you can use the REST API to deploy your model. So for authentication, you will be using the key and you will be using this key value that you have retrieved once you have created your language resource. And this is the header that you need to supply when you are calling a REST API. So this is the post request that you will be submitting to your endpoint. So endpoint is nothing but the one that you created a language service, so that you receive the endpoint, and then you specify which service it is. It is a language. And then here we are trying to do deploying a model. So to deploy a model, here what we are trying to do, we are trying to deploy a model related to analyzing the conversations, and this is the project name that you will be specifying that you create. Okay, conversational language project that you create before deploying the model, and then you will specify your model name, that is your deployment name basically, and then you specify the API version. Okay, so which version of API that you're trying to call, and in your request body you will include the model name. Okay, the model that you're trying to deploy. Okay, so this is how you will call your API to deploy your model to Azure AI language service. So when you have deployed, so you can check the deployment status by submitting a GET request to your endpoint. So here also you are just specifying your endpoint, language, and then it is analyze conversation, and then your project name and the deployment name that you have specified here, and the job ID. Once you have deployed your model, a job will be running. So that job ID you will be specifying here, okay, in your end GET request. And once you have submitted this GET request to your REST API, you will get a response status in this form. Okay, so here you will be getting your status as running if it is still running. Okay, if it is completed, then you will retrieve the status as completed, and you will also get created date time, last updated date time, expiration date time of your job ID. So this is just to understand how you can call your REST API. So once you have deployed your model has been deployed successfully. Now you have to query your model, right? So to query your model, you can either use SDKs that is available in C# and Python, or you can use your REST API also. So in order to use your SDK, you use a text analytics client class. Okay, so here we are creating the object of this class, and then we are supplying the endpoint of your Azure AI language service and the credentials, that is your key value. And using that instance of your text analytics client class, here let's say you want to do you want to extract the key phrases from your document. We have seen this in your first module also. So here is how you can call this extract key phrases method. Now coming to your REST API, you can submit a REST API request. In your request body, you will be specifying the kind, that is your language detection, and then model version, and what you're trying to do. Here we are trying to analyze an input. Okay, you want to analyze this text. Okay, you want to detect the language of this text. Here we have specified language detection. Now for conversational understanding, you will specify kind as conversation, and your input will be your conversation item. Okay, wherein you will specify ID, participant ID. So participant ID is nothing but here your user ID who is trying to who is trying to make a conversation, and then the text that user is trying to supply. And under your parameters, you need to specify here project name, deployment name. So why this? Because here we are trying to use your conversational trained model. Okay, the model that you have deployed, we are trying to use that model to do this conversation, right? So then you have to specify this project name and the deployment. So now let us understand the actual concept that is very important when you are trying to build your conversational language understanding model. That is nothing but your intent, utterances, and entity. So what is intent? Intent is nothing but a task or a action that user wants your system to perform, right? Let's say user want to retrieve the time, or it wants to retrieve the weather forecast, or you want your device to turn on. Let's say your user want to turn on the light. Okay, or user is just trying to do some greeting. Okay, so these are nothing but the intent that your system must understand from your user utterances. Now these are nothing but the intent that system is supposed to predict, and these are the utterances that user is going to say. So these are sentences, or I can say phrases. Okay, so when let's say user wants to retrieve the time, he will say what is the time. Okay, or let's say if user wants to turn on the fan, he can say switch on the fan, or he can say turn on the fan, or he can say on the fan, right? Or if he wants to check what the weather is, so it can ask, do I need an umbrella? Okay, or it can say, do I need a cap if it is sunny? So here user is trying to ask system certain thing, or it is asking to do some action like switching on the fan. So now user has to say something, and then system has to understand it, right? And then third thing comes the entities. Okay, so this is nothing but the piece of information that add context to your intent. Context in the sense to check what kind of entity that user is trying to refer here when it is asking system to perform certain action, or it is asking system to understand about something, right? So let's say when it is saying get time, what is the time? So now it system needs to know, so where this time needs to be checked, right? It needs to know what location that user is trying to ask the time. And then in case of turn on the device, so now system needs to understand what kind of device user wants to on or off, right? So here device can be your light, it can be your fan, right? So even for the weather condition, system needs to know, right, which location this weather that user is trying to ask for. So these three are the very important components before you try to build your custom conversational language understanding model. So these are the three things that you will be defining before you create your model. So now let us understand how you define these. So before you create your model, you will have to define the intent. Okay. So here you have to train your model using intents. So here intent will be associated with the utterance. Basically, you need to consider the domain, okay, domain of your business, which for which you are trying to build your language understanding model. And based on that domain, you define certain intents, okay, and you need to predict what kind of action that user might come and ask your model to do. Okay, so here utterance can be what time is it in London. Huh? So then your intent would be to get time, right? You need to train your model to understand that when this kind of utterance comes, then the intent would be to get the time, and your system must be able to extract this particular entity or the location as London, so that it can fully understand that it has to retrieve the time at location London. Okay, so let's say if utterance is something like, will I need an umbrella tonight? Okay, now your system should be able to understand that the intent here is to get the weather condition and at what time, as the user has specified tonight, then the time. So here entity is your time, which is nothing but tonight. Similarly, if your utterance is turn the light on, the intent is to turn on the device, and the device here is, the entity here is light. Okay, so how do you define these intents and entities? So you need to collect various utterances, various examples for your each intent. Okay, so you need to also check the length and the structure of your utterances. Like you need to specify short utterances, medium utterances, long utterances also for the same intent. And you can also include both with correct and incorrect grammars. So basically what I'm trying to say, you need to train your model with different kind of utterances for the same intent. And then you have to label your entities very precisely. You have to accurately label your entity. You need to make sure that you are not including anything which is irrelevant when you are trying to label your entities to train your model. It should be labeled consistently. That means across all your utterances, you need to label same way all your entities, so that your system will be able to train itself very well, that when a user comes and try to provide certain message, it will be able to accurately identify that intent and the entity. And you should ensure that all the instances of your entities are labeled. So you have to take care of these three definitions of your intent, of your utterances, of your entities. So when you're specifying before you train your model, so these are the things that you need to be very careful when you're defining your intent and then associating it to your utterances and entities. So now when it comes to types of entities, you can have three different categories. It can be learned entities. Basically, these are nothing but the entities that you specify in your training data. Okay, you label your data and you make your model to learn from those entities. Or you can have list entities. Okay, so when you are creating your model, you can specify list entities. So it is nothing but having certain set of possible values, like your days of week. Okay, your days of week can be Sunday, Monday, Tuesday. So you can specify synonyms. Like for Sunday, you can specify entity as SUN, for Monday MON. So so you have certain set of values for a particular entity. So here entity is your days of week, it has particular list of values. So you can specify list of entities. Apart from that, you can also use pre-built entities. So these are the common types like your numbers, your dates, your names, okay, names of your celebrities, names of your locations, names of your buildings. So these are the pre-built entities that you can feed into your system. So that way you can reduce the model training time. If you feed certain pre-built entities, then your model will be easily able to identify those entities from the user utterances. Okay, if you have already feed it with some pre-built entities. Now coming to how you can use the patterns to differentiate similar utterances, right? So here using these patterns can help you accurately differentiate between your similar utterances, right? So basically you need to focus on format and the key differences and make sure that your model understand and responds correctly. So why do we need these patterns? So here the problem is a user, two different user, okay, can provide similar kind of utterance, but the intent would be different in those two utterances. Okay, so different intents can have similar utterance. So it will make system to differentiate between those two utterances difficult, right? For example, if you say turn on the kitchen light and then you have a utterance is the kitchen light on or turn off the kitchen light. So here the intent of the user is different but structure is same, right? Entities are same and the even the phrases seems similar, right? So your model should be trained so precisely that it should be able to differentiate between these three utterances and understand the different intent. So what would be the solution to this kind of problem is you should use patterns to differentiate your intent with similar structure by defining the placeholder for entities like device name. So here if you see the device name is same but the intent in all these three utterances is different. So you can define the patterns when you are training your model wherein you will specify three different intents, three different utterances for same intent, okay, and then you specify the common device name there. So here you are specifying a substitute for your define device name. So turn on the device name, switch on the device name, turn on the device name. So for all these three patterns of utterances, your intent is turn on the device. So now model will be rightly trained that in these case only it has to perform this intent, that is turning on the device. Now your second utterance is the kitchen light on? So here you can train your model. So when this kind of utterance is coming, you need to get the device status. Okay, here it is a question kind of utterance wherein you need to get the device status, and here you have put a placeholder for your device name. So device name can be fan, light. So it depends on what user is trying to supply in its utterance. And then for the third utterance, turn off the device. You specify three different utterances. So it can be of this pattern. Turn the device name off, switch off the device name, turn off the device name. So what we're trying to do here is we are trying to train our model by supplying it with different patterns of the same utterance, or I must say utterances are different, intent would be same, right? But so we are trying to specify different patterns by specifying the placeholders for your entity. So once you have done this step of defining intent, utterances and your entities, now you will be training your model. So once you train your model, your Azure AI language service can learn to categorize the intents correctly based on the structure and the punctuations or based on the text that you have used in your utterance. Now coming to using pre-built entity components. So this is something important here. So this is a now if you see this particular screenshot, here you have entity components wherein you can define your learned components, and then there is a section something where you can define your pre-built components. So these are the predefined elements in your Azure AI language service that can automatically detect some common entities like your numbers, emails, URLs, or any choices. Okay, it all depends on what domain your business is. So this will help you to streamline your creation of language models without needing extensive training data for these entities. Let's say you have certain components or certain entity components that you already know that can be the part of the utterances from the user. So you can predefine them here, and then you need not train your model on those entities. Okay, so how do you use this pre-built entity component? You create a new entity here. Okay, and then select the pre-built, like you can just click on this add new pre-built entity, and you can specify your entities and the descriptions, and you can add up to 5 pre-built entities here, pre-built components per entity basically. So when you create an entity, you can add 5 pre-built components. So we'll see when we'll do the lab demo, and then it will be more clear. So using pre-built components will be reducing your development time and effort, and it will allow you to quickly deploy your conversational language understanding solutions, right? So these are the benefits of using this pre-built entity. And coming to your example, it can be something like contact info. Okay, so let's say your entity name is contact info. So under this you can add some 5 pre-built components. So contact info can be email, phone number, URL, address, right? And similarly you can define another pre-built entity with name like say date time info. So in your utterances, if you have some date or a time, year, month, so all those components can be part of your date time info entity. So these are some of the specifications and important points that you need to understand before you try to create your language understanding, conversational language understanding model basically. So we'll see in lab how you can build it and how you can define your intent and utterances. Thank you.